So you're probably wondering, well, if we can do the derivative of sine, cos, and tan, are there derivatives for cosecant, secant, and cotangent? Yes. Here they are. They're in your textbook as well. If you'd like to, you can memorize them. But what I find most people do with these ones is they just know sine, cos, and tan, and anytime you want to figure these out, you can just do that by doing 1 over sine for cosecant, 1 over cos for secant, and 1 over tan or cos over sine for cotangent. And then use your chain rules and stuff like that to figure that out. Do you want to see how that works for one of these? Which one do you want to do? Cosecant? So if you think of doing the derivative of 1 over sine, there's a couple of ways you could do that. You could either do the quotient rule, or probably a better strategy would be to change this to sine x to the negative 1. That makes it a chain rule. What's my derivative going to be? The negative is going to come out in front. That's going to stay the same. Subtract 1 from the exponent. Multiplied by the derivative of the inside, and the derivative of sine is cos. So here we have the derivative of cosecant. If you wanted to memorize this form of it, that would be fine as well. How did they come up with the form that they have? Well, they said, let's put that sine to the negative 2 is really a sine x squared on the bottom. So if I write that sine x on the bottom, and instead of writing it squared, I just write 2 of them multiplied by each other, then what do I get? Well, 1 over sine x is cosecant, and cos over sine is cotangent. So I have negative cosecant x from that one times by cotangent x from the first one. And it matches the same as what shows up as the formula. Okay? If you were asked for the derivative of cosecant and you wrote it in this form on a test, it would be perfectly fine. So the same thing you could do with the secant one, you could rearrange that. The same thing you could do with the cotangent one, you could rearrange that. Now, as far as memorizing these, some things that I kind of find a little bit helpful for memorizing them is if I think of some of my identities from last year. You know, you have sine squared plus cos squared equals 1. That formula rearranged became tan squared plus 1 equals secant squared. So you might remember that secants and tans go together from that formula. And then coincidentally, we've got, what's the derivative of tan? Secant squared. What's the derivative of secant? Secant tan. So they're still connected that way. Same thing with our formula that cotangent squared plus 1 is cosecant squared. Here we have the derivative of cotangent is negative cosecant squared. And the derivative of cosecant has a cosecant and a cotangent. The negative signs, where they go, that gets a little bit more complicated. I tend to find these ones I don't use as much. I seem to always go back to just figuring it out again using sine, cos, and tan. Because I find that easier than memorizing something I don't use very often and then forgetting it. So anytime I want to find it, I can always go back to my formulas. So using those formulas, try this one. And when you're done, you can check it up there to see if you got it right. So you want to cause yourself some pain? Well, there's the homework that you're going to work on tomorrow, but there is one right here. This would be a chain rule inside of a chain rule, 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 inside of a chain rule. We could do that. It's just really long, because all you do is the derivative of the most outside one, sine, is cos. Then you would have to rewrite all of this multiplied by the derivative of the inside. The inside, first inside one is cos. So So it'd be negative sine, and then you would rewrite all of this. Multiplied by the derivative of tan is secant squared, and then you would rewrite all of this. Then the derivative of cosecant is negative cosecant cotangent. So when you do negative cosecant cotangent, inside the cosecant you would write all of this, and inside the cotangent you would write all of this. Then the next inside one would be secant, and the derivative of secant is secant tangent, so you'd have secant cotangent x and tangent cotangent x. And finally you'd have the derivative of cotangent x, which you would write as negative cosecant squared x. So as far as how long that would take, you'd probably have to get longer paper and turn it landscape size if you wanted to see if you could attempt to do that all in one line. But yeah. So if I hadn't memorized these and I was doing this one, cotangent is cos over sine. So I would have 3 cos x over sine x minus, and cosecant is 1 over sine x. Those have a common denominator, so you could put them together if you'd like. Three cos x minus 1 all over sine x. Just because I had a common denominator. Now if I had this as a type of function that I was looking at, it says I should use the quotient rule. So I would go about doing this with the quotient rule, and you keep the bottom the same, multiply by the derivative of the top. The derivative of the top is going to be negative 3 sine x plus 0. Subtract, keep the top the same. Derivative of the bottom all over the bottom squared. And if it didn't ask me to simplify, I would leave it like this. Now, if you wanted to, you can now take what this is and as an identity, change it to that. So you'd say, how do I get what I have here to look like what we had in green? Now to get it to look like we have in green, the easiest way is to use the formulas we have. So when you're working on this in tomorrow's class, you might say, oh, I can do it with this way, but then it becomes an identity that I have to prove. Might have been easier if I had just started with the formulas to begin with. So that's a choice that you're going to have to make.